Veronica Castro and Donna Johnson of Erickson Institute's Early Math Collaborative will be presenting Let's Play and Learn Together. They will look at how math games can be used for playful, joyful math interactions at home. Their session will talk about developing positive mathematical mindsets while developing number sense and logical thinking. Participants will gain practical ideas to increase math access and engagement for pre-K through second grade children and their families. Please welcome Veronica and Donna.
Good afternoon, everyone. My name is Donna Johnson.
And I'm Veronica Castro.
And we're from the Early Math Collaborative at Erickson Institute. And today we're going to talk to you about games. We're going to talk about how we can play and learn at the same time, how we can play and learn together, and how all children and families can engage in mathematical thinking when they're playing games. So, Veronica, let's get started. Let's play some games.
Let's do it. Let's have some fun. So the first game we are going to play today is called NIM. It is a very easy game to play anywhere that you are at. All you need is 15 items. You can be playing at a restaurant while you're waiting for your food. You can play around the house. Just gather 15 things. We are grown-ups. We're going to start with 15 counters. If we are playing with younger children, though, we definitely want to start with less counters, starting with 7 with the really young children. And then on each turn, each player is going to have the option to pick 1, 2, or 3 counters. And at the end, whoever gets stuck with the last counter loses the game. So it helps to think of it as a poison pill. You don't want to be stuck with that poison pill. So we might need some strategy here, okay? So we're going to play this together, Donna and I, for you to get a sense of it. So for this first game, I will be player 1 and Donna will be player 2.
That's right.
So I can play 1, 2, or 3, and I want as many as I can get. So I'm going to take 3 counters.
Well, 3 sounds like a good number, so I'll take 3 too.
Okay. Well, I'm going to take 3 again because I like having a lot.
And you know what? Let's do 3 again.
Okay. Ooh. So now I have to make a decision. I want to take 3 again, but I don't want that last one. So I'm not going to take all 3. I'm going to leave Donna with that poison pill.
Thanks, Veronica.
Anytime, Donna.
So even though I lost, I actually like this game. So I want to play again. So let's set up the game so we can play again.
Donna's brave.
All
right, let's play. All right, well, 3 worked for me, so I'm going to take those 3 again.
Well, 3 did not work for me, so I'm going to use a different strategy. And this time I want to play with 2.
Okay. Well, I'm sticking with my 3.
So now I'm just thinking here, what should I do on this next move? Should I take 3? Should I take 2? Should I take 1? What move is going to guarantee that I beat Veronica?
So what should player 2 do to win this game for sure?
Okay, so let's see. If I take 3, that leaves me with 4 counters. And then Veronica's going to take 3 again because that's just what she does.
Yep.
And then I'm stuck with the last counter, which means I lose. So 3 is not the winning move for me, so I'm not going to take 3. But should I take 1 or should I take 2? And that's the question for you. So what we want you to do later on when the conference is over is to play NIM with someone else. Get 15 counters and play the game several times. And take turns, with the players going first. Veronica went first this time, but vary that. So player 1 one time, the second player goes first the other time. Pay attention to who wins the game and why that person won the game. And just try to see what strategy might make you more likely to be the winner. And then given that experience, go back. You can look at the handouts from our notes and tell me, which move should I do? Should I take 1 or should I take 2? Which one is going to guarantee the win?
Absolutely. So the app that we have used just to demonstrate this, but has a lot of great math apps available, is the Math Learning Center. Here you see the website here. So you can play this again virtually or with anything at home, anything at a restaurant, anywhere you're at. Honestly, as long as there's 15 things, you can play this game at home.
And ideally, they should be the 15 of the same things. So we're not distracted by different objects. So 15 sugar packs, 15 pennies, 15 buttons, just 15 of something.
So math games, we're talking about math games, but how would we define a math game? Well, if it's a game, there definitely has to be a challenger, right? So you need at least one other person to be playing in order for it to be a game. If not, it's really just an independent activity. We also need a set of rules that everybody needs to abide by depending on the game, right? And then there's normally a distinct finishing point. So for example, with NIM, it was that we did not want to be stuck with that last poison pill. So that ends the game, and then a new one can be started. And then, of course, the fact that it's a math game requires some math thinking as well.
So when we think about games, what are some benefits of math games? Well, the first benefit is going to be in terms of motivation. So playing a game is a really good, meaningful situation for the application of some math skills. So if you've got to get to the end of the board in terms of a path game, then you're going to need to count those spaces to get from start to finish. And so that's a good opportunity for children to practice their counting skills, to practice the stable order in terms of those number names, but it's done in such a way that it's fun. It's not just this rote recitation of math facts. Another motivation is that children choose to play. Because they're choosing to play the game and choosing to participate, generally they're going to enjoy it. Children love games. And if it's a real game where there's some challenge, there's some elements of surprise, they're going to want to come back to it again and again. And because they're coming back to it again and again, it's a great opportunity for them to develop their self-concept, develop a positive attitude about math. And also it's going to lower just the fear of failure and making a mistake. So it's a great environment to try new things, to explore a new math idea, and in a safe context where they're having fun.
Another benefit is the access that it provides for all children. Because it's a game, it's not really language heavy. They could do so quietly and still be practicing those skills, those math skills and strategies. It builds independence. The children, once they learn the game, they can play on their own. They can play with their friends. They can play with their siblings. The teacher is not required in order for them to play it. Mm-hmm. And then it is a great homeschool connection. Again, once the kids learn, they want to go and play it. They want to play it with a lot of people. So encouraging them to go home and invite their siblings, their parents, their cousins, all of their family to play. Play, because then that also increases their exposure to math. The more they're playing, the more they're becoming familiar with these mathematical concepts and building a stronger foundation.
And that increased exposure to math results in increased learning. So one great thing about math games is that children of different ages can play the same game at the same time, and they can learn from one another. Another benefit is that there's logical thinking going on. So when we were playing NIM and Veronica was beating me mercilessly, I had to stop and think about, wait a second, how can I win this game? So I was problem solving and trying to think of strategies, and children are going to do the same thing. They're going to bring all kinds of strategies into the situation because it's fun, it's challenging, and they want to win. And the last thing is that it's a great opportunity to assess where children are in terms of their mathematical understanding in a non-threatening situation. So as we're watching children to see how they're counting or how they're figuring out how many, it helps us to understand, what do children know?
Absolutely. So let's play with quantity cards, guys. So quantity cards, what? Are you talking about playing cards, Veronica? Well, we're all familiar with them, and with older kids, it would definitely be fine to play with a regular deck of cards. But for young children who are still trying to make these connections between quantities and numerals, they may get a little confusing. Donna, what do you notice about that card on top of this hand here?
Well, I see that this is a 3 of heart card. So I see the numeral 3. And as I count the cards, the hearts, I see 1, 2, 3 big hearts. But then I see 4 small hearts. So if I'm thinking about how many hearts, I'm going to say there's 7.
Yeah. So when young children are playing with these cards, they're looking at the numeral 3, but seeing the quantity 7. And that is a definite mismatch for them. It could really get confusing. There are cards available for purchase that are kid-friendly. They have 4 suits, just like a regular deck of cards with the numeral, but the quantity definitely matches the numeral here. Another thing that can be done with those playing cards is to just white out the extra parts for the really young children.
And there's also, there's also these cards that are quantity cards called Savvy Subitizing cards. And these cards are available for purchase from Christina Tondeval. And the neat thing about these is you can see the quantity in many different ways. So just for the quantity of 2, you see dots in a 10 frame, you see tally marks, you see fingers, you see the numeral, you see dots on a dice. There's a number of different ways you can see one quantity. In addition to that, many curriculum have quantity cards that come as a part of their math games pack. And so these are other ways to see quantities in different arrangements.
Absolutely. And if you don't want to purchase anything, you can make your own.
That's right.
This is just with some index cards and some dot stickers. You could use bingo markers as well. They don't have to be fancy at all. We do encourage, though, that and from pre-K down, you start with numbers up to 5. We want them to know those numbers like the back of their hand and all the relationships involved, which we'll get to in just a minute. For the older kids, for kindergarten and up, then you can increase the quantities, including some structures like a 10 frame to bring out more of those relationships and understandings.
And on our website, earlymath.erickson.edu, we have a couple of sets of quantity cards that you can download for free. The first set is from the quantities 1 to 5, and there are 6 suits in that deck. And then there's a deck from 1 to 10 that has 4 suits in that deck. And again, they give you different opportunities to see different quantities, the same quantity in different ways. And that's what we want children to see, that 3 is not just 3 in a diagonal like on the dice, but 3 can look many different ways. And once they understand that, they're able to recognize those small quantities in multiple situations.
Absolutely. So if you have not guessed already, the next 4 games that we're going to show you have to do with number sense, right? The quantity behind those numbers. And something the research has told us is that what children really need to know to have a good number sense is how numbers are related, number relationships. So here we are going to talk about 4 number relationships. And the first one just being the spatial arrangement, being able to recognize small quantities without having to count. So Donna's been talking about those arrangements. So the fact that 3 can be 3 like this, it can be 3 as a triangle, it could be 3 diagonally, but all of those, they're able to just see and know how many there are. 1 and 2 more and 1 and 2 less. This is not being able to count up or count down. This is not adding or subtracting. This is really just understanding where numbers are in relation to each other. What does 4 always come before 5? Is 8 always 2 less than 10? Just getting an idea of the order of numbers and how they relate to each other, how close and how far they are from one another.
And at how close and how far numbers are in relationship to one another, helps us to think about this benchmarks of 5 and 10. So 10 is a really important number in our number system. I mean, we have a base 10 system. We've got 10 fingers, and we know that 5 and 5 is 10. So understanding the relationship of numbers to 5 and to 10 is very important. How close am I, to 5? How far away am I from 10? So understanding those neighbor relationships, understanding the benchmarks of 5 and 10, how much do we have to get to that, are important concepts that don't just relate to the smaller numbers, but also apply to larger numbers. Our last number relationship is part whole. So understanding that inside larger numbers are smaller numbers, and we can decompose a larger number into smaller numbers, or we can compose or put together smaller numbers to make larger numbers. And all of these ideas, all of these understandings undergird arithmetic, algebraic thinking. So these 4 number relationships are really important for young children to really immerse themselves in.
Absolutely.
They can immerse themselves through games.
Yes. So we're going to introduce 4 games and watch some videos of children playing these games. But while you watch those videos, we want you to think about the opportunities these games bring to notice how numbers are related. We want you to notice the interaction between the adults or older children with the younger children, and the experience that everybody is having in playing the game. Okay, so we will be showing you 4 games: Capture, 1 through 10, Magic 10, and Salute. All of these have directions in your handouts, and we're going to start with Capture. So many of you may be familiar with it, and it may be called a different game. I think it's Top It in some places, but we, old school, know it as War. Okay, so you're going to take a deck of cards, some quantity cards, split them in half, and you got 2 players, right? And so both players will be flipping a card at the same time, and typically the higher card wins. Okay, so we are going to watch a video of me playing with my youngest son and see what you notice.
1, 2, 3.
I get the capture them.
Why? How do you know?
Because I have 4.
You have 4, and what do I have?
2.
4 is more than 2?
Mm-hmm.
Okay, ready? 1, 2, 3.
What is that?
What is that?
I have a 5. You had a 1 because there's only 1 hand.
There's 1 hand, but you know what we're counting on this hand?
Mm-mm. 5.
So there's 5 fingers and 5 dots. What does that mean? Who has more?
We both tied.
We tied, right? It's the same. So that means we have to flip again, and we're going to put them on top of this, because they're the same, so nobody wins, right? You don't have more, and I don't have more.
So
Same.
we're both.
So both the same. So now this one is going to tell us who gets all of these cards. Ready? 1, 2, 3. Ooh, now who wins?
You.
You. How do you know?
No, you.
I know. You said, oh, me. So how do you know that I win?
Because I have 1.
You have 1. And what do I have?
You have 5.
5.
You capture them.
So I captured all of these cards. Ready? 1, 2, 3.
Oh, that means.
Man.
Oh, if we put that one in the middle, that makes 5.
Oh, you're right. If we get 1 more, it's a 4.
It makes 5.
So what did you notice, Donna?
I noticed a lot of things, Veronica. I think the first thing that struck me was how much fun your son was having and how much fun you were having. So together, as you all are playing this math game, you're just enjoying the game. It's just the joy of it. So even before the math learning, it's the fun, which tells me that he's going to want to play it again and again and again. The second thing,
all the time.
The second thing, all the time, right. The second thing I noticed was when you played the 4 and he played the 2, he was able to see those quantities without counting. He didn't have to say 1, 2, 3, 4. He just knew it was 4. He was able to subitize or to see that quantity without counting. And the same thing with the 2, he was able to see those quantities and just know what they were. And he knew something about the relationship between 4 and 2. He could see that there were more dots on the 4 card than there were on the 2 card. When you both flipped him over and you had the hand and he had the 5 like a dice.
Yeah,
and
the
he was
slick
like,
move.
So he said slick. He knew that was 5, but it was very interesting because he said, you only have one hand. And that was a true statement. It was one hand if we were thinking about counting hands. But then you very wisely just kind of did this with your fingers and said, what are we counting? And then it was like, okay, it's 5. So then you asked a really interesting question when you said, so who has more? And he was able to know that they're the same. That 5 and 5 are the same regardless of how they look. And then when you flipped it over to play again and you got the 5 and he got the 1, again, just knowing that 5 is much more than 1. They're not close to one another. They're farther apart. And I really loved the last one where you flipped over the 4 dots and looked like a square and he flipped over the 1 dot. And he knew that the 4 was more than 1, but he also noticed something else. He noticed that if you took that 1 dot and put it in the middle, that it looked like the 5 on the dice. So again, that spatial arrangement can be so powerful for children to get a visual sense of what those small quantities look like. That also gives them a sense of the relationships that 4 and 1 more is 5, that he would get to that benchmark of 5 if he had 1 more. So all of these understandings are coming up as you're playing this game with quantity cards that allow you to see these relationships.
Right, that was what I was going to say too with just that 1. That wasn't the focus of it. We're not thinking about part, whole or any of that, but he's noticing because of the visuals on those cards. So the quantity cards really give more of an opportunity to see some of those number relationships.
Yeah. So if we think about those 4 number relationships, analyze it in terms of the features of the game of capture, spatial arrangements, we talked about that. Yes, we're going to see it. Especially if you're using quantity cards. With playing cards, and that's our PC. With playing cards, there's only one arrangement for the quantities. All the suits, all the 7s look the same, all the 3s look the same, all the 4s look the same. So you only get one arrangement. But when you're using quantity cards, you've got many different arrangements that you can compare and children can see. And that also gives them the opportunity to make some visual connections with other arrangements. With 1 and 2 more or less, you definitely get an opportunity to see that. I mean, we saw that when he saw that, that 4 and 2, that 2 was 2 less than 4. We saw that with the 4 and the 1, and he talked about if you had 1 more, you would be at 5. So again, great opportunities to see those 1 and 2 more and less relationships. Benchmarks of 5 and 10, for sure. We saw him. Well, he was thinking about it in terms of a benchmark of 5, but in terms of a visual benchmark, and just thought about that. You're only going to see that when you have the 5 and 10 frames. So then you can see how far away am I from 5. You can visually see if you've got a 5 frame or a 10 frame. You can see how many empty spaces, and that gives you some idea of how far away you are from 5 or 10. And then part, whole, it's not the focus of the game of capture, but your son did see that because of the cards that were pulled. Where he had the 4, he had the 1, and he was able to see that 4 and 1 make 5. Yeah. So some games have some features that are kind of tend to surface and other features that might not surface, but can depending on the cards that are played. And this is one reason why we're kind of encouraging the use of quantity cards. There's nothing wrong with playing cards. You just get much more distance, with quantity cards. And
more opportunities for math.
More opportunities for math. Thank you.
Yeah.
So how about we look at another game?
Well, we're going to look at some variations first, Donna.
That's right.
Because where the part, whole relationship is not the focus necessarily, you're with just the single card, there are variations we're going to see where that will be more prevalent, no matter what cards you use. So normally that game is played with the highest card winning, but it can be varied by playing the lowest card wins, right? Players can also flip 2 cards at a time. And then either add them together, and the higher or lower quantity captures the cards. For subtraction, they can also subtract, and same thing, vary it, whether it's the higher difference or the lower difference that captures the cards. For even older children, they can play and multiply those two cards. And again, setting the rule ahead of time, whether the higher card wins or the lower card wins. So those two cards definitely give more of an opportunity to see that part-whole relationship.
Exactly. That's what I was going to say, that those, the differences, the sums, the products, they all give that opportunity to see the part-whole relationship.
Yeah.
So our next game is going to be 1 through 10. And we talked a little bit about a 10 frame. This game in particular uses the structure of a 10 frame to help children see those relationships from 1 to 10. So the way the game board is set up is you're going to deal out 5 cards. Each player will deal out 5 cards on top, 5 cards on the bottom. So there'll be 10 cards that are in play. And then the remaining cards will go in the draw pile in the middle. You're only going to use the cards that are ace through 10. So the jack, the queen, and the king are going to be removed. And so the players will draw a card and figure out where in that 1 to 10 structure it goes. So it's a great opportunity for children to see their understanding, for you to see their understanding of where numerals are. Understanding that the 1 to 5 is going to be on the top, the 6 to 10 is going to be on the bottom, and we can get a chance to see how fragile or how grounded that understanding of those number relationships are. The variation, we're going to talk about it because in the video you're going to see the variation, and that's called garbage. And in garbage, the jack, the queen, and the king are also included. The jack and the king and the queen are garbage cards, so it's, in effect you lose your turn if you pull a jack or a queen. But the king is wild, which means you can use him to fill in any space that you have vacant that you need. So let's take a look at this family playing garbage, also known as 1 through 10, and just see what these children's understanding is.
No.
Seven.
No.
Nope.
I need that.
No, I just cannot win. 7. Okay. Oh, there is
It's a 4. There's like a bunch of 4s in here, and you didn't grab any of them.
Oh, yeah, because everybody took them.
No, look.
No,
They're all right there.
6 doesn't go in that spot. Count.
I'm so confused. What is your 2 cards?
So Veronica, what did you notice as you were watching them play the game?
So I noticed there's definitely that difference in ability. The older kids are just bam, bam, bam. You know, they know where the numbers are. This little one obviously needs a little bit more support, but he's showing that he knows a lot. When he pulls those smaller quantities, he doesn't have to do any counting. He knows, he subitizes them, he identifies the number, and he puts them right where they belong. When we get to those bigger numbers, though, we see that he has to count. And even loses track sometimes, but has to go back to the beginning to figure out where that 8 went, right? And still kind of lost track. So they're like, no, you know, but then he didn't have to go back and count. He knew that it just was the next spot over. At 8 went into the next spot after the 7 spot. And then when it came back around again and it was 6, he put it in that 7 spot again, which wasn't right. But then once he was corrected, it went to that spot right before. So yeah, a lot of learning, a lot of thinking going on. I mean, depending on who you play, I think, and it would have been interesting to ask, instead of just counting, we definitely want to ask questions like that. Well, what would be the one in the spot before? What would be in the spot, or just giving them other prompts to think about, not just, no, you're wrong. We want to encourage math thinking and not make it a negative experience.
I think that's a really good point, because even asking, does it go on the top row or the bottom row? Is it closer to the 10 or closer to the 1? Again, you're right. Those are great ways to get children thinking and not feel intimidated because they're wrong.
Right. So in terms of those number relationships, what are we seeing? Are we seeing spatial arrangements? I think, again, here we don't see it very much because they are playing cards and you just have that one view of that quantity. But you could play this game with quantity cards and you'll have more of those spatial arrangements to call their attention. Do we see 1 and 2 more and 1 and 2 less? Yeah, that's exactly what he was doing when he knew that it was just 1 over or 1 before without having to go back and count. Benchmarks of 5 and 10, absolutely. The structure of that 10 frame, like Donna said, and if you ask those questions in terms of, is it going to go on the top row, bottom row, is it closer to 1, is it closer to 5, is it closer to 6, is it closer to 10, those will bring up those relationships. And then in terms of part whole, we don't see that here. I think depending on whether or not you use quantity cards, again, children will pay attention to the cards, but that is definitely not the focus of this game. 1 and 2 more and 1 and 2 less, and benchmarks of 5 and 10 are definitely the focus here.
Yeah, I agree. So let's take a look at our third game, which is Magic 10. This is our third game. I like Magic 10. This is our second game, first of all, but I love Magic 10 because the goal of the game is to figure out what are those 3 cards that are hidden. It's almost like magic because you can't see them, but if you're thinking about it, you can figure it out. And so in this game, you start out with 4 cards laid face up, and then you've got a draw pile, and then you've got your 3 magic cards. And we're also only going to use cards from 1 to 9. So the ace through 9 card are the only cards that we're going to be using. So the 10, Jack, Queen, and King, if you're playing with a standard deck, come out. And if you're playing with the child-friendly deck, then you take out anything higher than 9. Okay? So we're going to watch a video of this game being played, and just pay attention to what are some of those mathematical concepts that children have to pay attention to, and what are the number relationships that we see children engaging in as they play this game.
Yes. So just to clarify, those bottom 4 cards are in play for both players, and they're pulling from the draw card to see if they can make a 10 with the card they pull and one of those 4 cards.
Yes.
Okay, so now you draw 1. Can you make a 10?
Nope.
Nope, so you put it down. All right, Adrian, your turn. No, Tanya?
No.
Okay. Okay, so you put it aside.
You said it.
Oh, 5 and 5. Okay, hold on. Looking at the cards that are in play, what card would you want to pull?
A 1 or a 4.
A 1 or a 4.
Ow. I hit my elbow. It's probably 8. Okay, now we pick up the magic.
Okay, so now you guys have to figure out what the 3 magic cards are.
I think it's this.
Okay, so can your pairs that you guys each made, can that help us figure out what is there? Can the in-play cards help you figure out what has to be in there?
Maybe.
What's in play?
What?
What's in play?
A 6, a 3. I need a 7.
So you need a 7 for that. What do you need for the other ones?
2 and a 4. 2, 7, 4.
So now you agree it's 2,
2, 7, 4.
7, and 4? All right, I guess.
4. 2, 7, 4.
All right, what did we notice there, Donna?
Well, there I noticed that, first of all, again, they were enjoying the game. So once they understood the rules of the game, when your oldest son picked up the first card and was like, I couldn't make a match. What do I do? And understand, okay, you just leave it there. And once they got the rules of the game that they're wanting to make combinations of 10, then it became just fun and engaging until they got down. And we were seeing that they didn't have to count either. So they're a little bit older, so they knew some of these combinations of 10. So they didn't have to count, 7, 8, 9, 10, and use their fingers. How many more did they need? So this was just reinforcement for them. But then when they got down to those last 3 cards, that's when they had to really do some problem solving. So they see the 3 cards and what do I need to get to make that? But you know what, Veronica, I just thought about something else. Before we got there, there was something that you did that was really strategic. There were 2 cards that were showing, and you asked them before they pulled, again, that problem solving. What cards would you want to pull, given that these are the 2 cards that are down? And they were able to look and to see, not just to match because they have the 2 cards there, but understanding what would they need, that missing add-in kind of problem. What would I need to make 10? And again, that just in this conversational fun time, really pushing children to use the skills that they're learning in math to apply outside of just the rote memorization and rote recitation of facts. So that was something that I really liked. And then we got to the last 3 cards, and then they had to think about what would those 3 cards be. And they were able to figure it out, again, based on the fact that they were trying to make combinations of 10. So that's the goal of that game. But as I found out, sometimes it doesn't quite work out as simply as you might end up with 3 cards that are showing, and then you have the 3 that you have to figure out. And that's what we're going to look at now.
Right, it gets a little trickier. Because in this game, they end up with a different situation. So let's watch this video and see how they handle it.
They've got the 3 magic cards that aren't showing, but instead of 3 cards that are showing, they've only got 1. So it's like, this is
the in-play quantity does not match the magic cards quantity. So, right, they've got to do some more thinking. They can't just think of the missing add-in because they're missing an add-in for 2 of those cards.
Yes.
Yeah. Okay.
So why do you think an ace is going to be in there, Xavier?
Because of the 9. 7 and
Okay.
ace.
So a 9 and ace. So one of those has to be an ace. How can we figure out the other 2 cards, though?
What? I don't know. It's a 7 and an 8.
A 7 and an 8?
Mm-hmm.
Why?
Because I have 1, 2 7s, and Xavier has 1.
Oh.
It's a
so
3 and
what's
7.
still out there?
3 and 7.
3.
One of these.
So you think the cards are 3, 7, and ace?
Mm-hmm. Yeah.
Okay, let's see.
7, 3. Told you. Ace.
Yeah.
I won.
All right. So here they had to take into account then what cards they had already had and how many combinations were out there, and figuring out, we still were missing a pair of, 7 and 3? Yeah.
Mm-hmm.
So that took a little bit more problem solving, might require some more support with some kids, but they're able to figure it out.
And they were using those number relationships again. So if we think about playing Magic 10 and those 4 number relationships, what was embedded in the structure of the game, what opportunities do children have? So spatial arrangements, again, not really a focus here. But as we think about the 1 more and 2 more and less, again, that's another one with Magic 10 that wasn't really a focus. As we think about benchmarks of 5 and 10, definitely benchmarks of 10 because they were trying to make combinations of 10. And part whole, absolutely, because we're seeing these 2 parts that make the whole. So every game is not going to use all 4 number relationships, but there are number relationships that can be experienced if we're playing a math game. We're going to quickly look at our last game, which is Salute. So Veronica, you can tell us a little bit about it. We're going to watch this quick video as we come to a close of our time together.
So here you need 3 players. 2 are actually playing against each other, and there has to be a caller. And what the players will do, they can either stick it to their forehead or put it somewhere where they cannot see it. So the forehead's a good place. They can just hold it there if it doesn't naturally stick. And then the caller looks at the quantities and they are going to call out the sum. And so the children will be able to see the other card, but not their own. So they have to figure out what that other addend is to equal the sum that the caller has just called out. Okay, so here we're going to watch. Right, he would call 12, and if the 9 card, I don't see the 9, but I can figure out the 3 by knowing that total. Okay.
11. 6. Yeah. No. I had 6. 7. 1. Yep. 16. 8. No. 6. 7. Yep. You got it. No, actually, no. Wait. You didn't have it.
Okay, do the next one. Just do the next round.
Yeah. 14. 9! Yes.
How many?
3! Yep.
All right, freeze. All right, we're gonna play a different game. It's called Magic 10.
I can see through the cards.
I know.
What did you notice there, Donna?
Well, I noticed a few things. First of all, the caller was doing a lot of work. His head was going back and forth as he's figuring out what's the sum that I'm trying to call out. The thing that I love about this video is the little girl on the left in the white shirt with the little black dots was very strategic. She didn't have to think about the math part because she could see through the cards. So all she had to do was count. And even though that's not necessarily the strategy that we wanted her to use, it was great to see children being creative in playing the game. So, and a note to adults, if we're going to have them play Salute, we want to make sure they can't see through the cards. And we want to, like the teacher just said, I know, and next time we'll do it a different way. But let's take a minute to think about the number relationships there. Spatial arrangements, depending on the type of card you're using, there are opportunities if you're using quantity cards. 1 more and 2 more and 1 less and 2 less. There's opportunities for children to think about that, especially if they're thinking about the quantity and how much they have, how close are they or how far away are they from that next number. Benchmarks of 5 and 10. They can, if they're thinking about adding 2 numbers that are more than 10, so they might think about getting to 10 and some more. So like when the sum was 16, they could have used the strategy of getting to 10 and then some more. And then this is definitely all about parts and wholes.
Absolutely.
So again, like we said before, many games give many opportunities for number relationships. As you're thinking about the games that you're using with your children, analyze the features of the games. Are there opportunities for them to engage in spatial arrangement? Magnitude, thinking about the relative size or position of numbers to one another. Benchmarks of 5 and 10, those anchor relationships. Combinations of 10, like we saw with Magic 10. And then part and whole relationships, like we saw especially with Salute, and then with Magic 10, that we want to be knowledgeable consumers, and we want to share. We have only so much time with children in the games that they play, so we want to maximize the math opportunities in those games. And as we're closing, we just want you to think about this particular thought, and it's going to come up on the screen in just a second. What books are to reading, games are to mathematics. And so if we think about what books are to reading, they open the window. They're practice, yes, but they open the window to children's comprehension, to their imagination. And games are something that shouldn't just be used on Friday afternoons for, at the end of the day, or when children finish all of their work and they deserve to play games. Games are critical and crucial to children deepening those foundational understandings, those math skills. The more children play games, the more comfortable and capable they feel as mathematicians. So we strongly encourage you to play games with children and engage them in mathematical conversation. If you've got any questions for us, because we are at the end of our time, feel free to reach out to us at our email addresses. And you can find many more resources, math games, and math ideas at earlymath.erickson.edu. It has been a pleasure spending our time exploring games with you. We hope you have a great rest of the conference.
Thanks for playing with us.